In this video we'll build a beautiful Hangman CLI game using Golang. Let's get started. So I'm in my projects directory. I will create a new directory called Hangman. I'll cd into it and initialize a new Go module using go mod init github.com/myname/hangman. Let's open up this in VS Code and create a new main Go file. We'll have package main and then func main. Now, if we think about the steps of our game, we would need to get a random word from a list of words, generate the word blanks. Say we have a word like PHP. We'll need to show the user 3 underscores. As they start guessing letters, we'll fill in the blanks. Step 3 would be show the word blanks and ask for letters. In step 4, we'll check the provided letters. Step 5, if no more lives left, show you lost message. Step 6, if word is guessed, show you won message. Finally, we'll have to repeat steps 3 to 6 until win or loss. Now for the first step, we'll need a list of words. So we'll have a words variable, which will be a slice of strings, and let's say we have PHP, JS, and Golang. What we need to do next is get a random word from the slice. We can have word equals words, and here we'll need a random number. But we have to be careful, that number cannot be bigger than the length of the slice minus 1. To get such number, we can use the mathrand package and call the int n function. This receives an integer and returns a random number from 0 to whatever number we passed in, but not including that number. So if we do int of 3, we would get either 0, 1, or 2, but not 3. Now, instead of hard-coding this number, we can get the length of the word slice. Let's print this out. Open the terminal, go run main.go, and here it is. Moving on to step 2, we need to generate the word blanks. We'll have a blanks variable, which will be a slice of strings, because as the user plays the game, we'll have to replace those blanks with the guessed letters. Now, to fill in the slice with underscores, we can loop through the word and use the append function. We'll do for range word, blanks equals append blanks underscore. Let's print this out. And here it is. On step 3, we need to show the blanks and ask for letters. Let's do the first part. We'll do fmt printf word modular s, letter, add a space, and then we'll use the string package to join in the blanks. Let's test it out, and we're good to go. Next up, we need to ask the user for letters. To do that, first, we'll need a place to store those letters. We'll have a variable called input of type string. Then we can use the fmt scanline function, which will receive the address of our input variable. The scanline function will wait for the user input until a new line is detected. So once you hit enter, it will stop reading. Let's print this out. Open the terminal, run the program. It's now waiting for input, type something in, and once we hit enter, it stops and we can see our letters. So we're now getting a random word, turning that word into blanks, show the user the blanks and ask for letters. We're storing the letters. The next thing we need to do is see if those letters can be found in the word. To do that, we'll loop through the input letters. We'll do for, and we'll omit the index as we don't need it. Input letter equals range input. And then inside this, we'll loop through the word letters. We'll do for I word letter equals range word. Here we need the index because we'll use it to replace the blank if the letter proves to be a correct guess. So if input letter equals word letter, then blanks of I equals input letter. But right now this is a rune type, so we'll have to convert it into a string. Let's go ahead and print the blanks. Open the terminal, run the program, type 2 letters, and there we go. For step 5, we'll need to introduce the concept of lives. We'll go here at the top and say we have an initial lives equal to, say, 5. Down here, where we check the letters, we'll decrease lives for each incorrect guess. We'll start by assuming the guess is incorrect, so we'll do correct guess equals false, and then if the letter does match, we'll set correct guess to true. After we're done looping through the word letters, if correct guess is false, we'll decrease lives. Let's go ahead and print lives as well. Open a terminal, run it, type 2 letters, and now we have 3 lives left. Now, if lives is lower or equal to 0, we lost the game. So let's do fmt printf, and I'll add a heart emoji, 0, word, modulo s, sorry, you lost. And let's also add a /n for a new line, and then the word. Let's test it out. I'll run it, enter many incorrect letters, and here's our message. Then, for our last case, if the word is equal to our blanks, and to turn the blanks, which is currently a slice, into a string, we can use the strings package and call the join function. If these two are equal, we'll do fmt printf heart emoji modulo d for digits, word, modulo s, you won, congrats, and then a new line. Lives for the digits, and word for the string. I'll open the terminal, run it, and guess the correct word. Now, our last problem is that this entire code only runs once. We are only asked once for the letters, regardless of how many lives we have left. We need to keep asking until we either have no more lives or we guess the word. Let's fix this wording here. Go doesn't like Boolean comparisons. And then we'll wrap steps 3 to 6 into a for loop. Then we'll break once we're out of lives, or if we won the game. And let's also show the remaining lives when we ask for letters. Let's do another test. I'll open the terminal, run the program. I already know the word, but I'll type in an incorrect letter. Lives are decreasing. Type one correct letter, and then the entire word. Now, one improvement we could make is, since all our words are in lowercase, we could make sure that the input comes in lowercase as well. Otherwise, an uppercase letter, even though correct, will be seen as an incorrect letter. So we'll do input equals, and we'll use the strings package to lower and then pass it the input. And lastly, let's go ahead and grab a huge list of words from the internet and paste it in. And since we have words varying in size, we could also vary our number of lives. Longer words might need a larger number of lives. We could do lives equals 2 times and get the length of the word. Let's open up the terminal, run the program, and there it is. This is how you can build a Hangman game in Go as a CLI application. Bye.